Okay, students, new point here we are considering the collision theory of the bimolecular reaction. Collision theory of the bimolecular reaction. First, tell me what is the bimolecular reactions. The reactions which involve the two reacting molecules are called bimolecular reactions. We have discussed in types of the reactions depending upon the molecularity: bimolecular reaction, unimolecular reaction, termolecular reaction, tetramolecular reactions, and so on. So unimolecular reactions is the reactions which involve only one reacting molecules are called unimolecular reactions. What is the bimolecular reactions? The reactions which involve the two reacting molecules are called bimolecular reactions, and reactions which involve the three reacting molecules are called termolecular reactions, and reactions which involve the four reacting molecules are called tetramolecular reactions. So we are discussing the collision theory of the bimolecular reactions. Okay. First point in this video is collision between the reactant molecules. Second point, we are discussing the activation energy, and third point, we are discussing the orientation of the reactant molecules. Okay. So to to occur the reactions, these three points are very important. Again, fourth point is also important, but we are discussing in the next video. This is the potential energy barrier. So collision between the reactant molecules. Chemical reaction occurs. First, consider the first point. Collision theory of in the collision theory of the biomolecular reactions. Collision between the reactant molecules. Chemical reactions occurs. Chemical reactions is a result when there is a collision between the reactant molecules. When the chemical reaction occurs, chemical reactions occurs when there is a collisions between the reactant molecules. Rate of reactions is equal to collisions, rate of collisions. So to occur the reaction, there is an important thing that there should be the collisions between the reactant molecules, and rate of collisions should be equal to the rate of reactions. So rate of reactions is equal to the rate of collisions. For gas phase reaction, number of collision is more or more. In the solid and liquid, there is a less collisions, but in case of the gaseous molecules, the gaseous reactions, the collisions between the reactant molecules is the far more. Okay, there are greater the collisions between the reactant molecules in case of the gaseous reaction. So to occur the reactions, collisions very important, but not only collisions is important, other factors is also important. But so occurring the reaction, there should be the colliding, there should be collisions between the reactant molecules. So chemical reactions occurs when there is a collisions between the reactant molecules. Rate of reactions is equal to rate of collisions. For gas phase reaction, number of collisions is far more, is greater in case than the liquid phase reactions or solid phase reactions. Okay. Now consider the second point, activation energy. The colliding molecules, that is the which molecules are collide to each other, they are called colliding reacting molecules. The colliding reacting molecules have possess the minimum kinetic energy, and this minimum kinetic energy is called activation energy. What is the activation energy? When reactions is started, there is a reacting molecules are collide to each other, and these colliding reacting molecules have colliding reacting molecules possess minimum kinetic energy. That minimum kinetic energy is called, this minimum kinetic energy is called activation energy. So the colliding reacting molecule possessing the minimum kinetic energy, and that kinetic energy is called activation energy. Greater the activation energy, slow the rate of reactions. Okay. Smaller the activation energy, higher is the rate of reaction. Higher is the rate of chemical reactions. So there should be minimum kinetic energy. Okay. Now consider the orientation of the reacting molecules. Also this point is also important for the chemical reaction occurring, the chemical reactions, orientation of the reactant molecules. To occur the reactions, reactant molecule should be proper orientations. To take place the reaction, to occur the reactions, reacting molecule should have proper orientation. If there is a improper orientation, the reaction should not take place. If there is a proper orientation, then the reactions takes place. Consider the following. Consider the reactions A plus Cb. A plus Cb gives AB plus C. Okay. The collision of A with C approaching towards then collision of A with C approaching towards then A would not lead the reaction. That is the collision of A takes place toward the C, then the reaction is not takes place. If the collisions of A takes place with B towards the B, if the collisions of A takes place with B, then the proper orientation takes place and reaction takes place. But if collision of A with C takes place, we have give the product AB. So collision of A should be toward the B. Should be toward the B. If the collision of A should be C, if the collision of A with C approaching towards, then the A would not lead the reactions. Consider this. This is the collisions. A is collision of A toward the C. There is a should formation of the A and C, but we have the product AB. So this is the no reaction takes place. There is a no reaction takes place because there is a improper orientations. Now consider the second case. Here A collision of A towards the B. Here the collision of A is toward the B. So there is a successful reaction. There is a proper orientations. Therefore reactions are takes place. Successful reactions are takes place. So reacting molecules, to occur the reactions, reacting molecules should have the proper orientation. If there is a improper orientation, the reaction should not takes place. If there is a proper orientation, reaction should be successfully takes place. And if there is a no proper orientation, there is a improper orientation, the reaction should not be leads, reaction should not takes place. Okay, I hope you are understood.